Come on, pop up. Okay. This came up in lab. Some of you have got your themes. You change the background. I like the dark background, and I found that the default in Eclipse makes sometimes some of the things that it is um, graying out or highlighting such that I can't see it. This interface is that I'm using here is a theme called Dev Style, and so meant to talk to you guys about it. It's a popular theme in Eclipse. You can free to download. It has some other options I haven't really looked at. One is a code together, which you can partner up and be writing code at the same time and collaborating. And so there's an option to enable that. There's also an icon designer, and then uh, but here, for instance, the graying out or shading out, you can still see, different code. If we go to help and you go to Eclipse Marketplace, oh, of course, my internet's not going to fire up, or maybe it will. We'll see. Um, and you look for dev style, DEVSTYLE. And so dev style, again, it gives you the option of an icon designer or this collaborate together, but you can uncheck those if you want to just get the color changing. And it finally did, almost. And so you look for dev style and just install it, and it will give you the options of a dark theme, higher contrast, a light theme, and a light theme with higher contrast. And so I like the dark theme, and so you can put it in there. Again, my internet's not working here the best. Okay, let me go to. Oh, come on, timeout or something. Kind of stuck in waiting for it to talk to the world. Oh, one of the things I was also going to show is if you have your screen all up and running, and even without the touch, so you have the last screen. If you change your SPI mode from divide by 4, for instance, to divide by 32 and make it real slow, try hit then reset and just watch how slowly your screen draws. Like we're running at 20 megahertz on the SPI to move all the data for 320 by 240 pixels times, you know, 16,000 or sorry, 65,000 colors. So if you look at that, there's a lot of information going by at 20 megahertz. If you slow down the SPI for SPI1 to maximum divisor, I think it's 328 kilobits or something, you'll just see the screen slowly draw. And if it timed out, I'd show you that. Oh, okay. Hey, look, dev style, dev. So there's darkest theme with dev style. So if you go and install that again, it gives you options for a few other things, but that's the theme that I have back there. It changes some of your icons, makes them look nicer and things. And it just goes through and does an install. It changes that startup. And I don't know if you've ever seen when mine is starting up, it gives you some little quote of the day or something that is in there as well. So let's go there.
Sorry, how did you open that window now? That was right in.
So you go under help, Eclipse Marketplace,
Okay.
and then you search for dev style and it'll pop up. And if you go look at it, I think 32,000 people downloaded it in the last month. Like it's a very, very popular theme. So that gives you the ability to do that. So let me just go here. So there's there is the screen where, you have your different buttons and things on it. And so, if I have red, there's my red button going, and there should be my green button going, you know, and you'll see when you go and touch it, it kind of changes it shows you that it's pressed. It kind of changes to a light blue. There is a whole theming style available for this kind of thing as well. You can decide that all the buttons have to be fuchsia. And so, you can basically using like cascading style sheets and tailor the look and feel of your buttons, your sliders, all of that to do that. Don't do that. Funny, it says I'm connected, but it's just acting so much like it is not. Hey?
When you're on battery, you're probably recommending it high performance.
Oh, yeah, maybe. So if I'm on, let's go to my connectivity, to my SPI1, and let's go to there and scroll down. And if this is grayed out, meaning you can't touch it because it's the prescaler that you change. And if I go to 328 kilobits, let's see if we can do that. Where I find sometimes it's handy, like just showing this as far as the screen, but just because you can transmit something fast, you may not want to. For instance, if I'm trying to debug something that's going wrong, if I'm running at 20 megahertz, that's kind of hard for me to look at. And so, in fact, I was trying to see if I could read back the display, and these SPI displays, you can't read the data back. There's no data coming back from the master in slave out pin. It's not toggling. On the 9488s, the slightly bigger screens, it is toggling. On this one, it is not. And I've found them talking about some in some screens from China, they just, I guess, save money and it's not reading data back, which means we can't put a sprite on the screen because we need to read the data underneath the sprite in order to replace it, which is okay. We have all of this other stuff to do. I don't think it generated properly. Yeah, it's giving me an error. Anyway, that's where you do it. I don't know why it's giving me an error all of a sudden. If you ever see that where it's like something to do with something you haven't done, it means it didn't generate right, and you need to go back and regenerate. Like this is talking about USB, we didn't touch USB. That means something messed up when it generated the code. Go back and regenerate the code. Okay, and so hopefully it'll work. Now coming up, I'll see if that works by the time we're done this. Let's go. Okay, in the next lab, we're going to use these two things. Okay, so next week's lab is using this and then using this as a serial to USB conversion device. We're not going to use it as a smart chip at all. We're going to disable the processor on board and just use the USB to serial link. Okay, so that's what we're using that for right now. We will use it as a processor. In here is an ESP32. In this one is an ESP8266. This is a single core processor. This is the node MCU. The actual little unit is right here. and that's called an ESP8266. These are about $3. Excuse me. This whole thing is probably $9 to $12. This is an ESP32 with a few more things in it. The ESP32 is, you'll often see it referred, there's a few families, but this one is dual core, really 3 cores. It's got a low power processor in it, but for the most part, we can think of it as having 2 cores. One of the big differences between the two of them, between an ESP32 and an ESP8266, this is Wi-Fi, this is Wi-Fi and Bluetooth, okay? This particular unit is called a Heltec, and it's a Heltec LoRa module. It has the ESP32, so it's got the Bluetooth and it's got the Wi-Fi, but it also has a long-range, low data rate interface chip on it, and it's an SX1276 LoRa chip. So it can do Wi-Fi, it can do Bluetooth, and we can talk to the LoRa chip. In addition, this also has a little OLED screen in order to get some data back. Both of these we're going to program using the Sketch interface, or we could use Visual Studio Code and Platform IO and things like that. But so we can program it in that environment by putting in, adding into the board development the compiler, C++ compiler, and all the necessary parts for the development environment to work under this sketch. Okay, so we will be using this as an ESP32. We will be using this as an ESP8266 in the Arduino environment. Next lab, we need some way of talking to this unit by itself and interfacing it to your computer. And so what we're going to do is I need a serial to USB. This module we're going to program as a modem, and so a Wi-Fi modem. And then we're going to give it what are known as AT commands to open up a wireless connection and talk to your computer. But I want you to be able to type the individual commands and see what's going on. So in order to do that, we need to interface to your computer. And so this has USB for programming, but the data is coming out some of the serial pins. They could have had it come out there, and there are versions of it that do, but the one I want to prove that this works, we're then going to take this and talk to your ARM board with it and use it as a Wi-Fi modem with it. Okay, so that's where we're going. To do that, I want to make sure that you have the AT setup in here working in the configuration that we need it to be working in. So we talk to it serial because that's eventually going to talk to our ARM, and we're going to talk to this Wi-Fi modem and make our ARM board connect to the internet. So in order to do that, I need this to be the modem. So we program the modem, but in order to test it, I need to be able to access it through the serial connections. So we have one of these, and this has USB and then goes and talks. So we're going to use the USB to serial interface that's on here to talk to this one. So we'll disable the processor because I don't want it getting in the way, and just use the USB interface on this to connect up to this one. And then we have USB plugged in here. This converts it to serial, talks to this guy, and we get our communications. Okay, once we prove that we can do that in that lab, we take this away, we connect this up to our ARM board, not in the same lab, it's another lab, and then we use our ARM board to talk to this to get Wi-Fi communications with our ARM board. Okay, so it's kind of like a little bit convoluted. The ESP8266s, they first came into the kind of maker hacker community when they noticed that this was a cool little chip to get Wi-Fi to other things using that same thing we're going to do. And then people went, wait a sec, this is a powerful enough little processor by itself. I can just code just using it. And there's lots of, it's in a lot of plugs that you get at Walmart. It's in some Wi-Fi controlled lights and all, is this guy. just by itself. Okay, but we're going to use it first in its original mode, and they've been constantly updating this little AT command set. So that's where we're going with this in the next week. So you'll need both of these. So hopefully dig them out for next time. Thanks.